Hello students, so today we will see this basic formula of calculus you use to solve many problems in calculus related to limits. So this formula says limit x tending 0 sin x upon x equal to 1, which means when x angle is very small, then sin x upon x is equal to 1, or in other words sin x and x are equal when x is infinitesimally small. So let us see how can we derive this formula, and I will show you two different ways to derive this formula. So let's start with first way. So in the first way, I will use the series expansion formula for sin x, and we teach sin x is equal to x minus x cube upon factorial 3 plus x to the power 5 upon factorial 5 minus x to the power 7 upon factorial 7 plus so on. And let's put this sin x expansion series formula in the left hand side of the given formula which we want to prove. So left hand side becomes limit x tending 0 and sin x becomes x minus x cube upon factorial 3 plus x to the power 5 upon factorial 5 minus x to the power 7 upon factorial 7 plus so on, and this whole thing divided by x. And now we can take x common from the numerator, and the remaining terms will be 1 minus x square upon factorial 3 plus x to the power 4 upon factorial 4 minus x to the power 6 upon factorial 6 plus and so on, and this whole thing divided by x. So now you can cancel this denominator x and numerator x. So one thing I will tell you here that I think you know that, then you can cancel x in numerator and denominator because x is not equal to 0. If x will be 0, then you can't cancel them. So it limit says limit x tending 0, so it is x is tending towards 0 but it is not equal to 0. That's why we could cancel the numerator and denominator x. Okay, so in the remaining terms there is no undefined term, so we can directly put x equal to 0 here. So now we will have 1 minus 0 plus 0 minus 0 plus 0, and all other terms you will get 0. So only the term left with v, that is 1, and that is equal to our right hand side. So we could prove that limit x tending 0 sin x upon x is equal to 1. So this was one way to prove this. We can show you another way of proving the same thing. So let us start. Second, I will make a very small right angle triangle. Very small, I mean to say the angle will be very small in that triangle. So suppose I have very small angled right angle triangle. Suppose this angle is here x, okay, and suppose this is a right angle triangle which is a right angle at point B. Yeah. Now if this angle x is very small, you can also assume that this AB, that is the part of a very big circle like this. Alright, you can consider that it is a part of a very big circle, and then C will be the center of the circle, and then you will write CB is equal to CA because both will be radii of same circle. So this you can assume only if the angle x is very small, and then AB will be part of an arc length, and then AC and BC will be radii of the same circle, so they should be equal. Okay, so let us write the things we want to prove here. So first I will write sin x. Sin x, from this diagram you can write perpendicular AB divided by hypotenuse which is AC, and by the basic definition of angle you know that that is equal to arc length divided by radius of the circle. So if you consider that AB is a part of a very large circle, then you can write that x is equal to arc length is AB divided by radius. Radius you can write any of them, AC or AB. So let's write AC. And now you can see that sin x value and x value which we have written both are same. So that's why we can say that sin x is equal to x, and therefore sin x divided by x, that will be 1. But very important thing, we have very initially told that x is very small angle, and how do we represent mathematically that? Limit x tending 0. X tending 0 means x is close to 0, x is very small but it is not equal to 0. That is also important to note. Yeah, so this way we could see there are two different ways to prove sin x upon x limit x tending 0 is equal to 1. The first way was using the series expansion formula for sin x, and the second way was using a geometrical method. So I hope you enjoyed this, and if you are enjoying my videos, then you can consider it subscribing, and that motivates me making more videos. And you can post your comments and questions in the comment section. I will try to answer them. So thank you very much, take care, and bye bye.